Okay, so we're going to start off. I want to do a couple of problems for you, and it's going to we're going to look at just 3 problems tonight. No, it's tonight for me. We're going to look at number 1. This is actually pretty easy. If you read through these situations, it's asking you to identify which test is appropriate. In the first one, it's categorical. The important thing I want to pay attention to is the fact that it says the account effects, right? Remember, with this particular test, there are a lot of different kinds of things that you can say. The word effects, relationships, obviously the word independence would work out. This is going to be a test for independence. You want to see if these 2 variables are related in some way. In the second one, this one should be easy, but a lot of people miss this because dollars is actually quantitative. Remember, categorical variables are the only things that work in the chi-square test. You can't use quantitative, or you can't use a chi-square test, any chi-square test, for a categorical or for a quantitative variable. Number 3, here again, if you know the words to look for, this is really just identifying the correct description. And this problem is talking about humanities, social sciences, science, and so forth. Is that different from its residential and its non-residential students? And so you're looking at 2 groups, possibly 2 different groups, and you want to know if they're the same or if they're different on a particular subject, what kind of courses they take. Obviously, that's key for homogeneity. So be careful, read the words, make sure that you know which ones you're looking for, which words you're looking for to identify it. If it had been goodness of fit, you would have been given a certain number of percentages that your theory or your theoretical sample should have gone to, but none of those brought that situation up. But number 4 does bring up the goodness of fit test. And so here we're going to be doing essentially phantom. I'm going to go ahead and put all the numbers out and kind of get that running first. So then we can we'll come back in and fill in the phantom part of this. Essentially, if you do number 4 from start to finish, it basically covers all of phantom from start to finish. Here what I've done was I went through and I've written it down just to kind of put my organization on the screen. And so these are the theoretical numbers that we're supposed to have, right? You got to figure this one out because they don't tell you in the paragraph, but they say the rest are brown. That means that there's always has to be 100%. If you don't have 100% of your categories when you're writing this out, it's not going to work. Whenever I'm working in the calculator for the goodness of fit test, because this is the test we didn't actually get to work out, we would have been doing a really great candy lab and it would have been a lot of fun, but that's not going to happen. Well, I suppose it could happen digitally, but that wouldn't be as fun. So I put all my numbers in L1. These are my observed values. L2, they're not going to give me these values. We have these percentages. And if I know the percentages, then I can figure out what goes in L2. In other words, it's really going to be the probability of the color, or the percentage, times the particular sample size for your problem. And so if you kind of add your totals up here, we can figure out what the total sample size is. Right? If you add them all up, you're going to get about 106, if I did my math right. So what I'm going to do now is I'm going to take the 106, I'm going to take the probability, which is in this list. I'm going to multiply these probabilities times the sample size here. Then I'm going to list those out. So 21.2, obviously you have quite a few probabilities repeating, so you don't have to do this every time. And I've got to list them all out here. Okay, this is going to be my observed. Make sure that your values correspond, right? If this is yellow, then that should be the expected value for yellow. Degree of freedom in this chapter, or in this particular test, this is the GOF test. It's always the number of categories minus 1. Be careful. Sometimes we want to say it's sample size minus 1. That's what it usually is. This one, it's the number of categories. We have 6 colors here, so 6 minus 1 is 5. You go to the calculator, and this is kind of ahead of the game, but this is your chi-squared value, and of course your p-value. Now, if we go back to the questions, in part A, it asks how many of each color should we expect to get in the bags? Well, that's kind of what we did in this group here. Okay, this is the GOF test for part B. Part C is simply to write out the null and alternative hypotheses. If you remember from class, I told you that in chi-square, we're always going to be working with a sentence and it's a complete sentence, by the way, for all three chi-squared tests. In this case, we're going to say that all colors are as the master foods claims, as that manufacturer claims they should be. The alternative is just the opposite of it. All colors are not as they claim. And if you do your test, now in the calculator you're going to be pulling up the GOF test. So if you press stat, go over to calculate, press up, you'll get there faster, and you're looking for chi-square and the GOF test. It's going to ask you for L1, it's going to ask you for L2. I'm going to put them in just like we wrote them on the screen. Part D is asking for the assumptions and conditions. This is the same four we're pretty used to. Randomness here, it's the candies are packaged in a random fashion. For our purposes here, we could assume that that is a reasonable assumption to make, even though they don't technically state it. Independence, bags are packaged very independently. Again, there's no reason to think that you have a particularly special bag that is more of one color or less of another color just because you picked it up. 10%, this is one of those scenarios where you only have 106 and the population is so much larger than the sample size that you probably could get away with not actually doing this one, but I wrote it out anyway. 106 is definitely less than 10% of all candies. Expected cell count, if you were doing this straightforward, kind of without like what I had done earlier, kind of doing it ahead of time, then this is where I would have calculated all of my expected values in this list up here. Anyway, I've got them done. I've got them written down. Remember, you got to write them down before you get credit for checking this assumption right here. So I just wrote C above since I'd already done it. E, also degree of freedom, we talked about that earlier. That's right here. They're 5. Always check your calculator. It's not always going to be right on the money. A lot of times it is. For sometimes it doesn't change over. So always double check that. Okay, for F, we did those. The chi-squared value is 9.3, and the p-value is 0.09716. I can copy that, put it down here. So now we're going to basically write our conclusion out for part G. And finally, for the conclusion, we're going to essentially, p-value is 0.097, so that's almost 10%. So we're going to filter reject or null in this case. We do not have enough evidence to say that the candies are packaged any differently than what the manufacturer claims they are. They would essentially, or you could write it straightforward. You could say the candies are packaged as the manufacturer claims, or the candies seem to be packaged as the manufacturer claims they are. And pretty much, I just want to make sure I keep all three things in there. I filter reject, my p-value is greater than my alpha, and then we would put it back into context of the problem. Talking about the candies or the manufacturer or the colors, somehow bring that into the same kind of context that everything's written into. And that pretty much takes us to the end of this question. In this example, this was a little bit of a different one. It's talking about fruit flies, and the tricky part here is that they're going to talk about a specific ratio that, instead of giving a percentage here, they're going to give you an existing ratio of numbers. It's this one, it's 9 to 3 to 3 to 1. And that would be nice if they'd given you a percentage, but it's actually not that bad. So let's talk about the phantom and just kind of run through it from there. The null hypothesis, this is still looking at a goodness of fit test. So the flies are in the genetic ratio, or the ratio that is mentioned in the paragraph. The alternative here is that they are not going to be in this ratio. The tricky part about getting the ratio right, if you've used ratios before, and I'll show you in just a minute, I just set up a short equation using the sample size to kind of make that out. We'll get to that once we get down to the expected cell count. For randomness, you are talking about are the traits random, and as far as we know, they may not be random. You could have said here, instead of traits are random, you could have said traits are representative of the population. That would have been fine too. Independence, these traits are obviously genetically, we're assuming we have random selection of flies, that they're not necessarily related in any way. genetically, so we'll say the traits are independent. 10%, in this example, if you add the 4 different values together, it gives you total sample size of how many flies were actually selected. It also tells you in the paragraph. It doesn't always tell you sample size, but we'll multiply it by 10. There's definitely less than 1,000 or more than 1,000 flies in the population. The next one is going to be expected cell count. This is the one where you kind of have to pause and you have to do a little bit of math. When you're looking at expected cell count, in this example, you are looking to take those ratios and set up a small equation. So a lot of times I like to write down observed and then expected, just to kind of, because this is how I'm going to write it in my calculator. It's going to be observed in L1 and it's going to be expected in L2. So I'm going to set it up like just like it's written, but at 9x plus 3x plus 3x plus 1x. And that's going to be equal to my sample size. And that doesn't really matter if I'm ever given a ratio. This is exactly how I'm going to solve it. And so if I add them all up and I divide by 16, that's going to get me what my actual original 1x is worth. And I know that the rest of them is either triple that value or it's 9 times that original value. And that's how we're going to get our expected cell count. And so I'll multiply by 3 and then by 9 to figure out what that values are going to be. And once you've got that, that's going to allow me to figure out how to write my expected cell counts. So 6.25 times 3 is 18.75 and then 56.25. With all that, I can build my expected cell count. I can go in and just list it out from there. Make sure that you put them in the same order. The first time I did this problem, I actually wrote them down backwards. I went smallest to largest just out of habit, and I got a chi-squared value of over 400 and a p-value of essentially 0. So that was kind of weird. And I realized that I had done that backwards. All these are graded in 5, so it passes. The name of the test, this is just going to be chi-squared test or GOF test. I don't normally write the word chi-squared. I'd usually write the symbol and then GOF test. Degree of freedom here is just like before with the M&M question. You've got number of categories, and this is in fact for traits. So it's pretty much if you take the length of your list, L1 or L2, it's always going to be one less than that, not your sample size. Coming down to the end, we've got t-scores and p-values. My chi-squared value is 5.6711, and the p-value is 0.1286. So this is a pretty large p-value with an alpha level just at 5%. So we're going to definitely be failing to reject our null. Remember again, talk about the p-value, talk about whether you reject it or failed to reject, and then put it back in context. In this example, degree of freedom, I tend to put that with the name of the test, but technically as long as it's just written somewhere, you're good to go. And to be completely honest, I don't know that that's really ever a requirement, but it's always nice to have that down just in case. So the fruit flies are going to be, we're going to assume that the fruit flies are distributed as the genetic ratio predicts them to be. And that takes us to the end of the video. If you have any questions about any of these questions, definitely try some other practice questions. Here again, most of these are pretty straightforward, but some of them are a little bit trickier. Try some of the rounds. So for example, if I assigned 9 or if I assigned 4, then you can do the following questions. Those are going to be a lot of the same if you want some extra practice. If you have any questions, please get in touch with me.